this is my A&E project on investigating KE and GPE using the bottle drop experiment. So for part A, we would be using an empty bottle of mass m, which we will take later, and drop it with an initial velocity of 0 through a height of s. We would then record the average time and fit it into this equation of motion to find the distance or the height in which the bottle is dropped and the final velocity v. So after dropping the bottle 3 times, the average time is 0.9466 seconds. We also know the mass now, which is 15 grams, and because gravity is 9.81 meters per second and the initial velocity is 0 meters per second, the equation of motion gives us 4.40 as the height in which the bottle is being dropped. To find final velocity v, we use this equation of motion, and we get 9.29 meters per second as our final velocity. Now that we know final velocity v and height s, we get to calculate kinetic energy and gravitational potential energy. Ke, using the value of v, we get 0.64672 joules. For GPE, we get 0.64716 joules using the value of h. We would expect that the value of GPE and KE should be the same because of the law of conservation of energy. But however, GPE is greater than KE because when the bottle falls, heat is lost to the surroundings and some of the energy is also converted to sound. The percentage uncertainty is calculated by the gravitational potential energy minus the kinetic energy over the GPE times 100%, which gives us a value of 0.07%. Two sources of errors in this experiment is 1. Human reaction errors, which is a systematic error, and the presence of air resistance. To improve the accuracy of this experiment, we can conduct it in vacuum, or we can use a laser beam timer to time the experiment. For part B, we are going to drop the bottle through the same distance, but this time with a parachute. Now I'm going to be making the parachute, which I would use a plastic bag, scissors, a marker, a ruler, and some rope, and then I have a puncher and some tape. So let's go make the parachute. Cute, and then it can fly. Ready to launch. So for part B, the average time is 1.79 seconds compared to 0.95 seconds for part A, the bottle without the parachute. So there's a significant time difference between the two. That means that the theory is correct. It takes a longer time because since we built a parachute, that means there is more upward force. That means more time taken to fall the same distance.